Hello everybody, and we're back again with redox reactions. Hopefully you are very excited about them. So this is the second part of the lecture. Let's look at it. So I left you off before with this nice little example, okay? So what did you do with it? I did a little bit of a bad thing. I wanted you guys to commit a mistake that is very common for students to commit. And then I wanted you to forever remember never to do this mistake again. Maybe some of you didn't even commit it, but let's look at it. So I asked you to separate this reaction into its half reactions, the oxidation and reduction half, and to tell me what is the total EMF of the cell, okay? The potential of the cell. So the oxidation half, which is happening at the anode, we have sodium losing electrons, right? And the reduction half, which is happening at the cathode, is we have chlorine gaining electrons and becoming negative. Oops. And what is the total E for this reaction? This is the mistake that I bet some of you made. I bet some of you went into sodium on page 268, where is the sodium, the third one down, and you said that the reduction potential for sodium is negative 2.71, and you said, so the oxidation potential must be positive 2.71 times 2, since there's 2 sodiums. No, 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 this is the mistake. You do not, when you get the reduction and oxidation potential and the total EMF of the cell, here it is, you do not want to multiply by the coefficients, okay? The coefficients, forget about them. This is the place that they're not important. It does not matter. So don't multiply by the coefficients. Still, the oxidation potential for sodium is simply positive 2.71. It's not 2.71 times 2. It's not that. So you do not multiply by the coefficient. If you did make the mistake, I'm very glad, because now you will never ever make it again. Sometimes the best way to learn is to make a mistake and then say, oh no, it really gets reinforced into your mind. Okay, very good. So it's just the oxidation potential is simply plus 2.71 volts for sodium, and the reduction potential for chlorine is plus 1.36. So what is the total EMF of the cell? That plus that, right? The total E of cell is the reduction potential of the thing being reduced and the oxidation potential of the thing being oxidized. So there it is. It's a huge whopping plus 4.07 volts. This is pretty big, right? So this is very spontaneous, and it's a galvanic reaction since it is spontaneous. Will change of G be negative or positive for this guy? That's right, it'll be negative. Okay, very good. Let's go on.